Hi everyone, my name is Rizky Irawan. I'd like to present the results of our research entitled Classification of Student Performance based on first half semester of online learning using fuzzy nearest neighbor. So here's the outline that will be discussed. For the first is the introduction. Based on government decision since the COVID-19 pandemic first appeared in Indonesia, teaching and learning activities are now carried out remotely from their respective homes, or we call online learning. This online learning is carried out by utilizing technology, which is divided into two ways, namely synchronously and asynchronously. There are several problems in this online learning. That is the obstacle of internet connections from students or lecturers, applications used, and both students and lecturers are not familiar with this online learning method. So the possible impact is the knowledge gained by students is not entirely accepted and the learning process to be suboptimal in achieving learning outcomes. Therefore, the purpose of this research is to make a classification of student performance in a course based on the first half semester of online learning. The first half semester of learning, it means the time from the beginning of the course until the middle of the semester. And reasons to use the first half semester of learning because it can describe the final score obtained and it is a strong predictor of the course score. So the first half semester of learning can be used to make a classification of student performance, which has the benefit of benchmark and anticipate for lecturers and students if students' learning efforts are suboptimal during the first half semester of learning. To make a classification, we collect students' activity data in LMS or Learning Management System and their scores. And then we use a machine learning approach to make a classification. So this is an appearance of Universitas Indonesia LMS. In this LMS, we can access material files, discussion forums, videos, and it can be used as a place for assessment, such as quizzes, etc. Next, we will discuss data and methods. These are variables that exist in the data used. We classify students into good and poor performance based on the final scores. If the final scores is greater than or equal to 70, the students have good performance. And if the final score is less than 70, the students have poor performance. We can see that the data used is imbalanced because it is dominated by students with good performance. And then we use machine learning approach to make a classification. One of the machine learning methods for classifying is KNN, which uses a measure of similarity between observations. In this research, we use modified of KNN method, namely fuzzy KNN. The way KNN works is to measure the proximity between instances with the Euclidean distance formula, which defined in equation 1. This is an algorithm of KNN. The first step is we calculate the distance from each observation in the testing data to the training data using equation 1. And then we find the k nearest neighbors for each observation on the testing data with the training data. And then the last one, we classify the testing data based on the majority of the nearest neighbor labels in the training data. The difference between the KNN and the fuzzy KNN methods is in the class classification process. In the KNN method, class classification in data is only seen based on the majority of the number of its closest neighbors. But in the fuzzy KNN method, it considers the value of membership when classifying classes to improve model performance. And these are the formulas to calculate the value of membership in data. And this is an algorithm of fuzzy KNN. We can see that we have to calculate the value of membership in training data and testing data. And then we classify the testing data based on the membership value of U, which has maximum value. The next one is methodology. These are the research steps. For the first step is we do data pre-processing, such as data cleansing, and then we convert the acquired scores into their average scores and do data normalization using the min-max formula. After that, we split the data into 80% training data and 20% testing data. Next, we implement the fuzzy Kainan method with two schemes. This is the implementation without balancing data and with balancing data using smooth method. After that, we test the build model with testing data, and then we do evaluation with two ways. That is 5-fold cross-validation and 10 data split trials. These are schemes of data balancing using smooth method. So the minority data is generated to 100% and 200%. The next is experimental result. The main focus of classification is students who have poor performance. So the recall value displayed in this slide is the recall for students with poor performance. This is an evaluation using 5-fold cross-validation. Based on the result, the fuzzy KNN and the KNN methods have poor recall values in all cases of K before data balancing. That is, the two methods cannot classify well for students who have poor performance. This is due to a class imbalance in the data. When the training process uses training data, it becomes biased towards the majority class, that is, students with good performance. After the smooth method was processed with 100% minority data generation, there was a decrease in the accuracy value compared to without smooth in both methods for each K value. However, at the same time, there was also an increase in the recall value in both methods. It means the classification results of students with poor performance are better. And then after the smooth method was processed with 200% minority data generation, the recall value of fuzzy KNN can reach until more than 50%. But there is still a decrease in the accuracy value. This is an evaluation using 10 data split trials, and the results are similar to 5-fold cross-validation. Both methods have poor recall values in all cases of K before data balancing. Here's the results after smooth was processed with 100% minority data generation. There was a decrease in the accuracy value and an increase in the recall value in both methods. And here's the result after smooth was processed with 200% minority data generation. The recall value of fuzzy KNN can reach until more than 50%. And the last one is conclusion. The implementation of the fuzzy KNN method has not yielded good classification results on imbalanced data regarding students with poor performance. Therefore, data balancing is carried out when conducting training on training data. After balancing the data using the smooth method, the classification results given by the fuzzy KNN method are improved. The smooth method in data balancing yielded reduced the accuracy but improved the recall. The result shows that the fuzzy KNN method yields better results compared to the KNN method. The best performance of the fuzzy KNN method can be seen from the recall value, where the best recall value can reach 53.65% and accuracy is 76.64% if using the 5-fold cross-validation after smooth process. And if the data is separated into 80% training data and 20% testing data with up to 10 trials, the best recall value of FZKNN is 51.07% and accuracy is 77.02% after smooth process. And these are reference we used. Thank you for your attention.